Morning, girls. To start off P4, we're going to go through how to do partial fractions today. It is actually chapter 2 in the textbook. We're going to do chapter 1, which is proof. We'll do that together. But for this lesson where it's just a video, I think partial fractions is an easier one to pick up from a video rather than talking it out between us. So partial fractions is basically a way of taking a single fraction that has, and this part is kind of the crucial bit, it has two distinct factors, linear factors in the denominator of the fraction, and we can split it into two separate fractions that have linear denominators. So basically the two factors that are on the bottom of your original fraction become the denominators of two separate fractions when we split them, and then they will have a constant term on the top, on the numerator of each of their fractions. I'm going to go through two slightly different ways of working it out. It's personal preference, which one you prefer. I actually tend to switch between them both depending on which one's easier in a specific question. Like you'll see in this example, the first method, in my opinion, is way easier than the second one. But sometimes the second method's easier than the first one, depending on the question. I tend to flip between them both. You can choose one and stick to it. It's entirely up to you how you prefer to answer these questions. So they always start off the same way. So we've got 6x minus 2 over x minus 3x plus 2, and we want to split it into partial fractions. So we can see the two linear factors on the bottom. They've made it nice and easy. It's already factorized. So our linear factors are x minus 3 and x plus 1. They are going to be the denominators of our two separate fractions. So we can rewrite 6x minus 2 over x minus 3 x plus 1 is identical to a over x minus 3 plus b over x plus 1. I don't really need the fractions, so I'm going to get rid of them. X plus 1. I'm still putting fractions, there we go. We want to work out what a and b are, so we need a method to find out what those two constants are on the top of the fractions. To do that, we need to get rid of the fractions. We need to cancel the fractions out. So I'm going to multiply everything through by x minus 3 x plus 1, which means I would end up with, I'd cancel them both on the first fraction, leaving me with just 6x minus 2. And then I would, when I multiply a over x minus 3 by x minus 3 x plus 1, the x minus 3's would cancel, leaving me with a x plus 1. And then similarly with b over x plus 1, when I multiply it by the two linear factors, the x plus 1's would cancel, leaving me with b x minus 3. So I have this now linear equation, which I can solve in two slightly different ways to calculate what a and b are. So the first way, I'm going to kind of split my page into two. The first way is by substitution. So I know if I substitute in, say, 3, then that b part at the end is going to cancel out because the bracket would be 0. So if x is 3, then I have 6 times 3 minus 2, which is 16, is equal to 3 plus 1 is 4a. And then the b's gone because 3 minus 3 is 0. So the b has cancelled out. So that means that 4 is equal to a. Yeah, that's it. We've worked out what a is. We can do similar to work out what b is by putting in -1 for x. That would cancel out the a bracket. I would have 6 times -1 is -6, minus 2 is -8, is equal to -1 minus, again, the a part would cancel out because that would now be 0. And then -1 minus 3 is -4, so minus 4b. Divide through by -4 gives me 2 is equal to b. So now I've solved it. So therefore, 6x minus 2 over, that line's really wobbly, x minus 3, x plus 1 is identical to 4 over x minus 3 plus 2 over x plus 1. So I have split the original fraction into partial fractions. That's how I do it by substitution. The second way is by comparing coefficients. And in this example, it's probably the more complicated way. So the first part's the same. I still end up with the same equation. 6x minus 2 is equal to ax plus 1 plus bx minus 3. I'm going to expand all of that out and get rid of the brackets. Is equal to ax plus a plus bx minus 3b. And then I'm going to collect all of the like terms. So I have 6x minus 2 is equal to, I've got ax plus bx, which is a plus b x. And then I've got a minus 3b. There's not a lot I can do there because they're just two separate constants. Now I'm going to compare them to the similar constants on the other side. So I know the x coefficient is 6 or a plus b. So a plus b has to be equal to 6. So I've kind of formed an equation there. Now again, depending on the question, it might be really straightforward and you might be able to immediately see that one of the unknowns, one of the a or b, is equal to a coefficient or constant on the left hand side, but this one's not quite as straightforward as that. So we have a plus b is equal to 6. We have the constant, which is negative 2 on the left hand side, is equal to a minus 3b, like that, and then we need to solve a simultaneous equation. So I'm gonna multiply this by 3, gives me 3a plus 3b equals 18. Then I am going to add these two together to cancel out the b's, gives me 4a equals 16. A equals 4, just like we found before, so a is 4. When we know that, we have substituting it back into this equation, gives me 4 plus b equals 6, so b has to be equal to 2. And then again, the final step would be to rewrite the partial fractions like that. I've run out of room to do it, and we've done it before anyway. But those are the two slightly different methods. Well, not slightly different, they are very different. The two different methods of working out the numerators for the partial fractions. Like I say, I tend to switch between them both depending on the question. Sometimes it's really easy to just see straight away by comparing coefficients, and then you can kind of go through it a bit easier by kind of substituting in things and working it out. Or you can do it by substitution and methodically eliminating each of the constants A and B and C sometimes, which we'll look at in the next example, until we found all three. So that's the two different methods. Now, we can have a partial fraction where we've got three linear fractions on the bottom, three linear factors on the bottom. So this time we've got x minus 1, and we've got 2x plus 1. We know that 6x squared plus 5x minus 2 over x plus 1, 2x plus 1 is identical to a over x plus b over x minus 1 plus c over 2x plus 1. So we have taken each of the linear factors, and we have split them up into three different partial fractions. We want to find a, b, and c. The first step is the same, so we are going to cancel everything out. Multiply through by the denominator, and from there things will cancel. So we get 6x squared, because the full denominator is going to cancel on the first one, is equal to, on the second one, we're going to have a x minus 1, 2x plus 1, because only the x is going to cancel with the denominator there. We've got b x, 2x plus 1, and then we've got plus cx, x minus 1. So it looks something like that. What's going to be easiest to do here? Yeah, definitely a bit of substitution. So I am going to start by letting x equal 0. So that the b and the c part cancels out because we're multiplying by 0. So we get 0 plus 0, so minus 2 is equal to 0 minus 1 is minus 1, 0 plus 1, so minus 1a, which means a is equal to 2 when we get rid of the negative. Okay, then I'm going to substitute in 1 to eliminate all of the x minus 1 brackets. So that would give me 6 plus 5 is 11, minus 2 is 9, is equal to, we'd get the b part, so we'd get b times 1 is b, 2 times 1 is 2, 3, so 3b. Divide 3 by 3 gives you b is equal to 3. Nice and easy. And then last one, let x equal a half, negative a half. Yeah, to cancel out all of the 2x plus 1 fractions. Yeah, so I get, it's too early in the morning to do this in my head. A negative a half squared is 1 over 4. So I have 6 over 4 plus, minus 5 over 2 minus 2 is equal to negative a half c, negative a half minus 1. Now I'm going to need my calculator. So 6 over 4 minus 5 over 2 minus 2 is negative 3. That's nice. And then minus a half minus 1 is negative 3 over 2. Multiply it by negative a half. Negative a half is 3/4. So I get 3/4 c over here. So divide by 3/4 gives me 4. C is equal to 4. Negative 4. Oh, because it's minus 3. Yeah, of course. Negative 4. Now I've got what a, b, and c are. I can put them back into the partial fractions and I have my solution. So 6x squared plus 5x minus 2 is identical to, they should be 3 lines. Obviously, if you miss that in an exam, you're not going to miss a mark. But mathematically, to use the proper notation, they are identical to whatever value x takes. Each side of the equation is equal to each other. So that is identical to 2 over x plus 3 over x minus 1 minus 4 over 2x plus 1. And that's it, we're done. So that is the first part of this chapter, and we're going to stop there today. As we go through, we look at what happens if we have like a repeated factor on the bottom. What else? An improper fraction. And then that's chapter 2 done. So it's kind of going to take like 3 lessons, I'd say. But just to kind of get your head around the basics, to try out the different methods, see what you prefer. Obviously, I've used substitution in the second one. You still could have done it by using comparing coefficients. But like I say, sometimes that's really obvious and really easy. Sometimes not so much. So have a go, work your way through the exercise, see what you prefer, and then I will see you guys on Wednesday for decision, where we're going to continue doing linear programming. Yeah, okay. Yeah, right, brilliant. Okay, thanks girls, and I will see you on Wednesday. Have a lovely day. Bye.